going to start the course on nanotechnology in chemical engineering. So, today we will discuss about introductions, the types of materials. So, in the contents we will discuss basically types of nanomaterials, that is based on classes, based on materials and based on dimensions. So, the first two, that is based on classes and materials, both are almost similar, and third one, that is the based on dimensions. So, that particularly we will discuss here. A list means classifications of the nanomaterials. So, means nanomaterial that is based on classes I said, so that we can classify or we can categorize that materials. So, that is metallic materials, ceramic materials, polymeric materials and composite based nanomaterials, electronic materials and biomaterials. And so, when we classify that materials, whatever the materials will synthesize, that is based on materials, means that is carbon based nanomaterials, inorganic based nanomaterials, organic based nanomaterials, composite based nanomaterials. So, and then classifications, if we classify the nanomaterials based on their dimensions, whether it is 0 dimensions, 1 dimensions, 2 dimensions or third dimensions or 3 dimensions of materials. So, this way also you can classify. So, based on classes, the materials, that is metallic materials, ceramic materials or polymerics or composite based materials or electronics or biomaterials. So, these are the things we will discuss. So, means whatever in nature there are lot of materials that is exist naturally. So, at the same time we are also preparing a varieties of materials by using various precursors. So, we can start and produce a lot of materials. So, that would be a class of these nanomaterials. So, here we will discuss this metallic, ceramic, polymeric, whatever the materials are, composite, electronic, biomaterials or nanomaterials. So, metallic materials, first one, that is, so it consists of one or two metallic elements and in some cases small additions of non-metallic element or substance that we can put in that to prepare that materials. So, we have to use one or two metal elements and at the same time to another non-metallic elements we can use. So, to prepare out metallic materials. So, here means that metals we can consider any one. So, means cobalt, nickel, copper, aluminums, whatever the materials we need. So, that is metallic component and non-metallic component, that may be carbon, silicons, nitrogens, that we can use as a non-metallic elements to prepare the metallic materials. Okay. So, here one examples we can say that is the steel based example. So, it is made of irons and carbons. So, iron is the metal component and carbon is the non-metals or non-metallic elements that is used to prepare steel. Okay. In this particular type of metallic materials, the materials metallic type of bonds is present, and as a result that materials are good thermals as well as electrical conductors, and they are also ductiles at room temperatures. So, another one is the ceramic materials. This is ionic in nature and covalent in nature as well as. So, in this ceramic type of materials, it consists at least two different elements. So, similarly it also mixture of metals and non-metallic elements, and since it is metal is present, so therefore ionic natures may be there in that particular materials. At the same time, since non-metallic component is present in that to prepare the ceramic material, therefore covalent bond or nature or covalent natures, both the type of ionic covalent natures may be present in that particular materials. So, here few examples we are going to show. One is the glasses, bricks, stones, porcelains. These are the classic examples of ceramic materials. Since whenever we are going to prepare these materials, it consists of metal as well as non-metallic elements. So, therefore, these materials means having hard, brittle and good insulators. At the same time, these materials we can apply for a corrosive resistance, means since these materials having corrosive resistant properties. So, we can apply where means that particular properties is required for a particular application. So, these are the materials we can prepare, so we can apply for that particular system. So, there is another type, that is polymeric type of materials. So, in this particular type of materials, so here long chain molecules or organic molecules that we can use to prepare these polymeric materials. So in nature there are many natural polymers, biopolymers, synthetic polymers. Those are the things, means in natural polymers that are examples are wood, rubber, wools. These are the natural polymers that is available. In biomaterials, so protein, enzyme, cellulose, these are the cellulose, these are the biopolymers, so biological example. And synthetic polymers, by using organic molecules we can prepare, that is Teflon, Kevlar. So these are the synthetic polymers. So synthetic polymers, so that is one kind of elastomers having large elongations and low strength, and so also plastic which exhibit large variations in properties. These polymeric materials are good insulator materials. So where we need to apply insulating materials, so these polymeric materials we can prepare, so we can apply for that particular applications. Also these materials having good corrosion resistance, so that materials also we can use for this particular purpose. So then composite materials, so it is means this particular composite materials where we can use two or more materials with very distinct properties, and so once we mix them up and prepare this particular composite materials, then it would gives a different property materials. So that would be different property from the initially we have started those materials. So that is called synergistic property or synergistic act to create property of different from each single materials at the beginnings we have taken to prepare this composite materials. So these materials having one of the means once we have or using two different materials, one of the materials must be reinforcing phases. So reinforcing phase means maybe that metal or ceramic or polymers, whatever, depending upon the target materials we are going to prepare or we are having applications. So here the composite materials, we said we have two different materials that we can use to prepare say new materials, that is composite materials. So that composite materials we can also classify or we can categorize as metal matrix, ceramic matrix or polymer matrix. So if we use metals, so then it is metal matrix. If we use ceramic, then ceramic matrix. If we use polymer, then polymer matrix. So here's a few examples I'll discuss. So what are the called metal matrix composite? In that matrix materials I said that would be metals, that may be alumina, magnesium, copper, titanium, alloy, any kind of materials maybe the we have to use as a matrix, and with that we have to use reinforcing materials, that may be silicon carbide, boron, carbon fibers, any ceramic materials or any metals, that both will be mixed up, and that metal matrix composite materials we can prepare. Similarly, ceramic matrix composite also we can prepare. So here matrix materials, that would be silicon carbide, alumina or other ceramic materials, and reinforcing material that may be carbon fibers, silicon carbide fiber or other any ceramic materials or fibers that we can use to prepare the ceramic matrix composites. Okay. So that ceramic matrix composite having carbon silicon carbide, that is ceramic matrix composite, it having high temperature applications or many places we can apply where we have to means hold or sustain a high temperature. So in that case means rocket nozzles, jet engines components, so there so we can use this type of ceramic matrix composites, silicon carbides, carbon silicon carbides or alumina composite mixtures or composite ceramic matrix we can use. And another one is the polymer matrix composite, that matrix materials we can say epoxies, polyesters, phenolics, silicones, nylons or polyethylene, polycarbonate. These are the matrix materials we can composite or mix with the reinforcing material, that is carbon fiber, glasses, fiber, ceramics or other any materials that we can use to make a composite materials. That materials we can prepare or we can use for many applications to prepare the fiberglass boards or panels. Many applications are available, so it has been used. So these are the composite materials. Apart from that, there are electronic materials. So electronic materials also made of metal, ceramics or polymers I said. So if it is coppers, that is used as a electronic chips, interconnecting material, so that is, or ceramics, that is also means material, that is silica, that used as a optical fibers. There is another polymer or polyamides that is used as a dielectric materials for electronic applications. So these are the various applications or materials. So as electronic materials we can use or we can prepare those materials. Apart from that, there is biomaterials I said. So that materials naturally or synthetically, means biomaterials whatever we prepare lab scales, means lab scales the materials that is designed to mimic or augment or replace to the biological functions, means that is totally different materials. Whatever the materials will prepare, that should be compatible with the human body and not introduce any rejections that materials. So that materials we can prepare and we can use for a particular, means substitute of the applications of where it is required. So there we can use that type of materials. So there are a lot of applications those biomaterials, that is prostheses, implants or surgical instruments. There in many places that biomaterials can be applied. So that means similar type of materials. So we can use the biomaterials, not exactly from bio-based materials. Bio-based material depends. So biomaterial, that is synthetic material that can be applied for that particular applications. Okay. So now another way of we can the materials we can prepare, so that is nanomaterials. We can classify or we can see that way. So that materials based on materials. So here I said that materials we can say carbon based materials, inorganic based, organic based and composite based materials. So this is carbon based materials, that is made of carbons basically. So there are a lot of examples of there, fullerenes, quantum dots, graphenes, graphene oxides, many materials are there. So that is made of basically carbons. So this is one class of materials. So these materials in nanoscales whatever that we prepare, so that can be used many applications. Many applications are there. So that we will discuss later. So these are the carbon based nanomaterials, fullerenes, graphenes, carbon dots or carbon blacks, carbon quantum dots. So these are the materials, carbon based materials. Later another class of material, that is inorganic based materials. So this type of materials may be metals or any metal oxides, but that should be in nanoparticles or nano range. So that materials we can use to prepare that particular nanomaterial. So if we talk about the metals nanomaterials, so that is iron, cobalt, irons, gold, silvers, whatever the metals that we can use as a starting materials, or that materials from the precursors we can start and we can prepare nanoscale in that particular materials. Or ceramic type of material, that may be silicon dioxide, titanium dioxide, alumina. So these are the oxide materials or ceramic materials. And semiconductor materials also, zinc oxide, zirconium oxides also, these are the materials we can classify, we can categorize them inorganic based nanomaterials. So they have lot of applications. So these are the means inorganic nanoparticles or nanomaterials. So you can say, so this way magnetic, ceramic or semiconductor type of materials. So other types I said organic based materials or nanomaterials, that is made of organic materials. So organic compounds we can use to start this, or we can prepare those type of materials. One classical example, dendrimers, liposomes, ferritins. So these are the materials, organic based nanomaterials we can prepare, or these are the examples. So protein based nanomaterials, lipid based nanomaterials or polymeric based nanomaterials, carbohydrate based nanomaterials. So these are basically prepared nanomaterials or nanocompounds that is prepared from organic matters. Okay. So then composite material, that is also similarly two different materials we can composite, means mix them up and prepares the materials, that is totally new materials, that is also in nanoscales, means nanomaterials, but property would be different from the starting or beginning that materials you have taken. So this type of composite materials usually prepare to increase or enhance the property of that particular materials. That property may be thermal resistance or conductivity, any property. If you want to modify, you want to change, then with the precursors, that polymer matrix we can use and prepare the nano composite material. So here precursors with polymer matrix they have used, and then the nano composite materials we can prepare. Here we can use monomers and nanoparticles. So then we can develop this type of nano composite, or we can use monomers with the precursors, then we can means this composite materials we can prepare. and that we can apply for a specific applications where we need to use that particular materials to change or improve that property of that materials where it is applied or it is required. Okay. So, next another class of nanomaterials that is based on dimensions. So, here you can see x, y, z, that is the 3 dimensions. So, means the materials whatever we can prepare, so we can classify depending upon their dimensions. So, 0 dimensions, 1 dimensions, 2 dimensional or 3 dimensions the materials we can say based on their number of dimensions exist the materials we have prepared. Of course, that dimensions should be less than 100 nanometers, then we can say that material should be nanomaterials, otherwise that would be a bulk material. So, I said at the beginning that once we prepared a nanomaterials from starting with a bulk materials, the property would change abruptly that materials. So, therefore, in case of 0 dimensional, 1 dimensional or 2D materials, the property is different from the large scale or bulk scale material. So, therefore, this type of materials have a lot of applications, lot of importance. So, those materials we can use or we can synthesize. So, this type of whatever the nanomaterials I said 0 dimensional, 1 dimensional or 2 dimensional materials, 3 dimensional materials that may be amorphous or that may be crystalline materials or that may be single crystalline, polycrystalline materials that may be composed of single elements or multi chemical elements present in that particular materials, and that may be various shapes also and various forms also, and they exist individually or incorporated in the matrix or whatever we said in the composite, and at the same times that materials may be a metallic, ceramic or polymeric materials. Okay, so first we will discuss about the 0 dimensional materials. So, I said all the dimensions means the materials whenever the materials we have prepared or that is exist that may be in the nanoscales. So, once the materials whatever we have prepared, so it has x, y, z 3 dimensions. So, all dimensions would be in the nanoscales. So, then that materials we can set 0 dimensional materials. So, no dimensions larger than 100 nanometers. If x, y, z all 3 should be in the nano range less than 100 nanometers, then the materials we can set the materials should be 0 dimensional materials. Okay. So, for example is nanoparticles, we can prepare that materials and it has x, y, z all dimensions are at 100 nanometers, then means this is also in nanometer range, this is also in nanometer range, this is also in nanometer range. So, we can say that the material is 0 dimensional material. So, here nanoparticles you can ACM image you can same time image. So, we can see. So, in that particular material, so here x, y, z dimensions all dimensions is in the nanoscale. So, this particular nanoparticles. Another one is the 1 dimensional. So, in this particular here also ACM image you can see. So, here's whatever the materials that is carbon nanotubes you can say, nanowires, nanodots, these are the classical examples. So, here out of 3 dimensions 1 dimension at least should be in the nanoscales. So, x may be in less than 100 nanometers. So, y and z may not be. So, then that materials we can set 1 dimensional materials. Okay. So, this is in dimensions or diameters of that materials is nanometer range, but length is not in nanometers. So, then we can say it is a 1 dimensional materials. Then 2D materials, so where the materials you can say both the dimensions may be in the range of nanometer range, and third dimensions that may not be in nano range. So, then we can consider 2D materials, another 3D materials. So, that is also all the dimensions that none of them are in a nano range. So, then we can say that is the bulk material. So, here whatever the materials that we are preparing, so the dimensions not in the range of nano. So, bulk materials we can say. Here one examples I am giving means the materials means here's a TAME image you can see, that is platinum alloy and nanoparticles that has been prepared a particular methods, and its dimensions that is less than 2 nanometer, less than 100 nanometers. So, whatever x, y, z. So, this materials is one example for 0 dimensional nanomaterials or nanoparticles you can say, and this is carbon nanorods or carbon nanotubes you can say. Here this is the diameters that is in the range of nanometer cross sections whatever. So, and this is the length may not be a nano range, so it may be more than 100 nanometer, 200 nanometer. So, one of the dimensions that is in the nano range, so therefore the material is one dimensional. Another one is two dimensional materials. So, here's multi-layered structures that TM image is showing here. So, here platinums at the tops of our coppers that was prepared. So, top layer in nano coating of platinum. So, that is you can say the thickness of this particular materials coated over that particular surface. So, that is in nano range both x and y. So, that materials we can say it is a 2D materials. In this particular materials is thickness or length whatever, that would be in the nano range, thickness should be in the nano range, that materials. Even the internal structure also you can see here, the nanocrystallines means the materials consist of nanoparticles and nanocrystallines. So, that is also in the range of nanometers. Okay. And this is nanocrystallines, this is microcrystalline. So, here's whatever the structure here forms, so that is not in narrow range. So, here much more bigger than this. So, here's whatever the materials or internal structure formation is there, that is in nanoscales, but here it is micro scale or larger than that. So, 3D materials or bulk materials you can see where none of the dimensions, all 3 dimensions, that is more than 100 nanometers. So, here same or same image you can see. So, here these materials, or you can say this material is 3D materials, 3D bulk materials. Still why it is called nanomaterials means this 3D or 3D nanometer, we are saying this is bulk materials, as well as we are saying it is nanomaterials, since the bulk materials composed of this materials, particularly whatever we have prepared, it is a multiple arrangement of nano size crystals and different orientations. So, here these materials when it was prepared means the materials consist of lot of nano size crystals, and the orientation of different crystals, that is also in nanometer range. So, that is why we are saying it is nanomaterials, but 3D nanomaterials, and the particle size or materials is more than 100 nanometers. Okay. So, here's 3D nanocrystalline materials that has been shown in 3 dimensions. Okay. So, now different type of means materials, so we have discussed about 0D, 1D, 2D and 3D materials. So, here few examples you can say, 0 dimensional nanoparticles we can say, and 1 dimensional materials, that is nanowires, nanotubes, nanorods, and 2 dimensional materials, that is nanofilms, nanolayers or nanocoatings whatever. So, those are 2 dimensional materials, and 3 dimensional materials, that is bulk materials. So, here you can see that example. So, 0 dimensional materials, so fullerenes we can say that is a 0 dimensional materials, carbon dots, graphene dots, nanodiamonds. So, that examples of 0 dimensional materials. Okay. Similarly, 1 dimensional materials, that is whatever I said, nanowire, nanotubes. So, here you can say multi-wall, single wall, whatever carbon nanotubes, those are 1 dimensional materials. And number 2, 2D dimensionals, that is graphene sheets you can say, graphene oxides, those are classical example of 2D materials. And 3D material, that is bulk material. So, graphites, that is consist of graphenes, but multiple layers that is present. So, height or thickness you can say, that is made of lot of layers of that graphenes, that is graphite. So, you can say that material is 3D materials. Okay. So, here's one tables I am summarized. So, considering different type of category means 0 dimensional, 1 dimensional, 2D and 3D materials. So, whatever we have discussed, so that is summarized based on their dimensions means, and one example is there quantum dots also we can say, or nanoparticles. So, that is 0 dimensional. So, this type of materials having unique properties means high surface area to volume ratio. So, this type of materials having unique properties means, so when the materials changes its dimensions large to smaller, as small as possible 0 dimensions, the surface area changes extremely high. Okay. So, and 1D materials, that is they are also having high aspect ratio, and 2D type of materials that ultra thin properties means 2 dimensional materials, then whenever it is required to coating any surface. So, ultra thin coatings materials and materials which exist in very nano range of the dimension thickness. So that materials having high surface area to volume ratio extremely high for that type of materials. 3D type of material also having large surface area, but compared to 0D, 1D and 2D materials, compared to those materials, this material having less surface area to volume ratio also less or lower than those materials. So these are the applications of 0D, 2D 1D material, 2D materials and 3D materials. So depending upon our materials available or synthesis, a particular materials we can prepare and we can apply or utilize for a particular application. So depending upon the method of synthesis, so we can prepare and we can apply that materials in a particular applications. So here that means whatever we have discussed in previous slides. So here in the form of structures, individual materials that I am showing here. So 0D materials, 1D materials, that is maybe means here first column, that is 0 dimensional materials, carbon materials, this is inorganic materials, gold nanoparticles, organic materials, liposomes, and nano composites, that is core cells, the materials that having 0 dimensions. And here's 1 dimensionals, that is carbonious material, that is CNT, inorganic material, that is zinc oxide nanorods, and CNC, that is cellulose nanocrystals, that is organic materials, and nanofibers, that is nanocomposites, made of three different materials composite, but that material is 1D materials and that is nanocomposite materials. And 2D material, that is I said graphene, magazine, COF, that is covalent organic framework. So that we can say that as a 2D materials, that is made of organic materials. And this type of layer structure composite materials also we can prepare, that is 2D materials, and 3D, that is graphites, 3D morph, dendrimers, polymer matrix. So these are the 3D materials, that materials made of a particular starting material, that may be either carbonious materials, inorganic, organic or nanocomposite. So this way you can classify or we can characterize or we can means divided that materials whatever we prepare in the nano range, that we can classify based on the starting materials we have started and prepared that materials. Okay, so thank you.